All right, y'all, today we are going to talk about trig models. So we're focusing on what applications all of these graphs that we've been working with have in real life. Okay, so the first thing I'm going to have you do is you have this activity sheet, and I'm going to have you work through looking at this table and just answering the first two questions you see on here. Okay, so think about what parent function might be applicable based on what they say, and then think about the items you need to write that equation by hand, and then after you do that, you're going to come back to the video so we can chat. Okay, so hopefully you got sine or cosine. It really doesn't matter here. It depends on what you're thinking. We know that this is alternating back and forth between values. We're going starting with a low number of daylight hours, then our highest, and then it starts going down again, and then keeps repeating. And so anything that repeats like that, cycling through the same values, is periodic, which means we have one of our trig functions as the parent function. And specifically, sine and cosine both cycle through some maximum and minimum value without restriction. And so that's what we're looking for. Now, whether you decide sine or cosine is really a personal preference based on pattern, and we're going to get into that a little bit more with the Desmos activities that's going to help us visualize these points, okay? So when you are asked to write an equation by hand, the things that we need, if you think about your note card, are the b value, which we know goes with the amplitude. And you don't have to write these in any particular order. I just want to chat about each of them. We need the a value, which deals with the period of the graph. We need the translation, the h value. That's our shift left and right. And then we need our k value, the shift up and down. And this, remember, is also called the midline. And all of these things are going to be the same, the amplitude, the period, and the midline, for whether you use sine or cosine, except for the h value. That's the only one that is going to change when we use a different parent function, depending on where our feature has gone, either the midline or the maximum, depending on the parent function we choose. Okay? So what I want you to do before we get on to Desmos is I want you to think a little bit more on how these relate to the graph, and specifically how they relate to these points that we're seeing. So before we go to the graph, I want you to look at these points and see if you can figure out any of these values, the amplitude, the period, the h value, once you decide a parent function, or the midline, and you may not be able to find all of them, but see if you can think about algebraically how they would relate to the numbers there. Pause the video and try that for me. Okay. We're going to take a look now at how these each work. So right now on our graph, on our table here, we have a minimum value of this 933, and we have a maximum value. Highest one that I see here is this 1454. And this is actually going to help us find both the amplitude and the midline. But the first thing we want to do is get rid of these weird times and change them to regular decimals. So when we're thinking about this, it's 9 hours and 33 minutes. That's the same thing as 9 full hours plus 33 minutes out of the 60 minutes that are in an hour to convert it to a decimal. So that's 9.55 hours. We can do the same thing with the second one, 14 plus 54 over 60, and that is 14.9 hours. And that's telling us we are cycling between that high and that low value. And so we can use that to find the middle, because the middle is just the average of those two values. So if I want to find an average, I just take the numbers and add them up, and then I split it in half. So my midline can be found algebraically by that visual. If I don't have it, I can sketch a little picture, but just by taking the middle value of my max and min, which for us is 12.225. So I know that. Okay, and the amplitude can be found from there, and there's actually two ways you can do this. If you find the midline first, then all you have to do is take your maximum or your minimum minus that. I'm going to take 14.9 minus that value we just got, and that gives me 2.675. Okay, or when we talk about amplitude, we know it's the distance from here up, and that's the math that we just did. But it's also, if we think about it, half of this total distance. So the other way we can do it if we don't know the midline is take the distance between max and min, so that means subtract the values. That's the whole length, and it's half of that distance. And it's going to give us that same value. So two ways for that amplitude. Okay. The last thing that algebraically we're going to be able to determine really from this table is the period. The period is how long it takes to start repeating itself. Hopefully you notice that this 9.33 showed up twice, and it wouldn't necessarily have to be precisely the same, because in real life that's not always perfect. And in fact, this was to minutes. We could have gone minutes to seconds, and it definitely wouldn't have matched up perfectly then. But we're really using a close estimation. So that means from 1 to 13 months, or a period of 12 months, we have our repeat happening. And hopefully that makes sense, because 12 months is our calendar year. But that helps us solve for the a value, because if you recall from your note card, we take 2 pi times a to get to the period. And if we know that period, we can set that equation equal and solve for a, just dividing by 2 pi on both sides. So now we just figured out that a, this part reduces to 6, but that pi stays on the bottom, so 6 over pi. Which means when we go to put our equation, we have to use the reciprocal. Now the only thing that's not going to be obvious from this, and I say obvious, but the only thing that's not very easy to determine on h, it's actually pretty challenging to determine from here, is this translation. Okay, the other ones, yes, they take practice to get used to, but it's possible. In the h, it's not necessarily possible directly. So what we're going to do is talk about the graph in reference to it versus trying to go through the algebra using these points. Okay, so that's where our Desmos is going to come into play, and we'll put this equation all together. So either I gave you a code for the Desmos, or you can find the link for it on Canvas, the agenda page. Okay, so you want to go to the Desmos activity. Again, either I gave it to you or it is on Canvas, so check that out. And it should look something like this when it pops up. Okay. What we're going to do is talk about how we can write an equation using those pieces we just talked about. And I have you writing this equation to match the points, and I actually physically graph them. We can see it's making this sine or cosine wave. And with this sine cosine wave, what we want to do is come up with a parent function with our adjustments that matches these points as closely as possible. And so we're going to really start with the ones that we already determined, and then kind of talk through how we can get h from there. So depending on your parent function, that's going to tell us which h value is relevant. So I'm going to start talking just about the pieces that we do know. And we decided our amplitude was 2.675. That goes first. And then I'm just going to pick sine to start with, because that's what they have here, but in general you get to pick whatever. And then we're going to fill in some of these pieces, and we'll talk about cosine as well. So then the next thing is 1 over a. And recall our a value that we solved for just a little bit ago was 6 over pi. So the equation is going to flip that and say pi over 6 instead. So when you type this in, you can physically type pi, and it'll change it, or you can click on this keyboard, and pi shows up right there as well. Then divide it by 6. You do need these extra parentheses, assuming you have an h value, so check those there. Put your x. I'm going to close those parentheses for now, because h is the last thing we're going to talk about. Close them again, and then we're doing our plus k, which we decided was 12 point, I think it was 225. I'll double check. Yes. Okay, so right now our graph looks pretty good. We have size-wise, it looks about the right width. It's the same height and low point, maybe a little bit lower for some of these values, but it's pretty dang close to those. The problem is we have to shift over to make this match. So with sine, we need to figure out how much to shift this over, or how much their distance is between any 2 points that correspond on this graph. Okay, so you can use, like I said, any points. If you want to go from where this maximum shows up to where our maximum is showing up, that works, because it doesn't matter that this is sine. In fact, that might be easier for you to see than thinking about the translation from the midline. Okay, remember, and I'm going to draw this on just the side here so we can see it. Remember, when we're talking about the translation of h, we're talking about where does this original point shift over to. And that original point on sine is at the midline. For our graph, the midline is at 12 and some change. And so for us, it would fall somewhere between these 2 points, which means our h value would be somewhere between these 2 points down here, somewhere between the 3 and the 4 range. But you can also find that from here, if we count from max to max, there's 1, 2, 3, and maybe a little bit more than 3, or very close to 4. So I'm going to start with that. So inside, remember, it's the opposite of the direction we're going. So -4 is a good start, and then you look at it, and we're just going to adjust it based on what we see. It looks like we're a little bit too far over with most of the points. It fits on that one, but most of these points are on the left side of the line. So we're going to change that to maybe 3.8. And that looks pretty close. You may want to just keep playing with numbers until you get to a point where you're happy. Okay, but that's how it works with sine. If you wanted to use cosine, there's 2 ways you could do it. You could use cosine and find this point. Okay, same concept, the maximum, if you go down to where it is, we can use a translation of about 7. So if I change this to cosine and change this to about 7, again, shift these over a little bit. Looks like we went a little bit too far, so maybe we call it 6.7. And then that looks a little bit better. Or a lot of people liked, because this graph started in our table at the lowest value, a lot of people wanted to use a negative cosine, or reflection. And if there's a negative cosine, we don't have much shift at all. So there's the parent function. I don't have any shift. But it does look like it moves over somewhat, maybe about 1. So if I do -1, again, looks pretty good, and you adjust from there until you get to a number that you're happy with. Okay? Once you're happy with what it looks like, hit submit, and we're going to move on to the next part. The next part, what we're going to do, if you took advanced probability and stats, okay, we did a little bit of this so far, but not all of you may have done that, so we're going to go through this together pretty slowly to talk about how we can use our calculator actually to come up with regression models. It's a fancy name for talking about a curve or a line of best fit. Okay, so you did line of best fits in algebra, okay, but not all equations are linear. We're going to talk about a sine model. And your calculator actually defaults to sine as the parent function, because we know both sine and cosine can be translated onto each other. So it's always going to use the parent function sine. But the benefit of doing this, it actually allows us to use all of the values to come up with the curve, rather than just using the maximum and minimum values that we use to come up with the equation that we first typed in. Okay, so you're going to want a calculator here. And what you're going to do is we can put these values into lists. It basically creates a table for us in our calculator. And how you do that is you hit this stat button, because you'll see this list is above it. But it's really a statistic measure that we're doing when we talk about regression equations. So you hit stat, and then this edit button lets you edit the numbers that show up in your list. Okay? You shouldn't have anything in your list, but if you do, you're going to go up, and I'm only going to do this for list 1 because it's easy for me to retype these in. I'm not going to do it for list 2 because those will take a while to type in. Okay, so if you need to clear it out, you highlight the top, you hit clear, and then you go enter, and it clears it out for you. So now what we're going to do is type in our x values, which are 1, 2, 3, and I'm just hitting enter after every number I type in. And you want to go slowly enough so that you don't miss any. It's really important that we do this carefully. And what I generally have folks do after they type in everything is just double check it, glance over, make sure the numbers don't look too funny, and they're following the same pattern as our table. Okay? So scrolling back up, double checking that 1 through 24 are showing up and we didn't hit anything weird. Okay, then you're going to go to the second list. Again, if you have to clear it out, you can. I'm not going to do that for this just because I already have these entered. I'll still show you how it works. Okay, you'll notice here that my numbers are not matching the table or the values on your paper because that on your paper says 9 hours and 33 minutes. We're going to have to convert these just like we did for finding the maximum and the minimum hours. So we're going to do this by just in the cell typing 9 plus 33 over 60 and then hitting enter. And then the next one, 10 plus 17 over 60, hit enter. Okay, all the way through. I want you to pause the video and type in all of those. When you're done, come back and we'll talk about next steps. Okay. After all of your information is in your list, and it's really important that you do this with us, okay, after your information is in your list, the next step is to actually calculate the regression model. And that function is a function in your calculator, again, under the stat button. So hit stat, and then we're calculating it. So over at the top, go over calculate. And then here are all the different things you can do. So these things that end with REG are regression models. So you could do a linear, line of best fit. You could do a quadratic. But we're doing a sine regression. So you're going to scroll down until you see sine reg. And it's towards the bottom. So that's number C. Click enter. And this screen may or may not show up on your calculator. You're just going to hit enter until the equation pops up. So enter for me just scrolls down my list until I see calculate, so I can hit enter to actually make the equation pop up. But these are the values that are going to go into your equation. Okay, so when we go back here, okay, our equation is going to go on the line here. And because we are rounding, and Desmos tells you to round to 3 decimal places right here, okay, since we are rounding, we're going to say approximately, and just steal those numbers from the calculator. So about 2.649, and then sine comes next, because that's the parent function I said they always use. Then this letter B comes next, so we're writing this number, 0.523, then X, then says plus C, they call C negative, so minus 1.902, close it. And then on the end, we're adding the D value. Notice they're using A, B, C, D. It's always alphabetical for however many variables they have. You're just going to pay attention to the order they write it at the top in the equation and match that. Okay, so then you can put that equation into your Desmos. Okay, just type it in there, hit submit, and then you're going to answer those last questions on your Desmos. Go ahead and submit when you're done. Pause the video to take care of those, and then come back for the last couple questions on your practice. Okay, so to answer these couple questions here, we have to use this equation, and your calculator has that equation stored where we can actually use it and graph it. We had it on Desmos just so you could see that visual and work with it, and we could tie it to what we did last time. But in the future, when we have this big ugly table, we're just going to use this regression model to help us answer questions, okay, because it's pretty accurate. It uses all the points rather than just a couple of them, so that makes it a little bit nicer for us. So it says, what does our equation predict for February 1st of this year? So we have to figure out, compared to our data, where February 1st falls. So right here, it told us this is from January 2020. So this number 2 would represent February of 2020. And so we just need to know how many years after 2020 is it currently. So for right now, it's 2023. That's 3 years later. So that is 36 months later. So this would be 38. Okay, depending on what year you're watching this video, that may not be the same case. Okay, so what we're going to do now is talk about how we can do some calculator stuff to get that value. One thing you can do is always just plug it in by hand and put it here, but we rounded this. So if we want a more precise answer, we're actually going to do this all in the graph. Okay, so I'm going to show you another feature. Go to your y equals for me and clear out anything that is there. And here's what I want you to do. In your calculator, this equation is stored. It's under this vars button. So hit vars. And then we're talking about stats. So go to statistics number 5. And we want the equation that we found. So over to equation. Regression equation is right up top. You hit enter. And it pastes that whole equation for you. Look at all those decimals. Okay, from there, what we have to do is we have to turn what's called your plots on. Your plots just mean the points that are plotted in our list. So if you go to second and then y equals, your first plot, we want to hit enter on, and we want to change that to on. Okay, so just scroll down, highlight on, hit enter. And the type we want to be a scatter plot. It should be already selected, but if not, go ahead, highlight enter. And that's the only thing you'll change from those screens. Your last step, you're going to hit zoom. And there's just like our zoom 6 gives us a 10 by 10, there's a zoom stat that automatically fits our window to the points in our table. So we're going to use zoom 9. Okay, and that graphs the points and our equation. Okay, so but again, that window is just fitting to the points that we have in our table. We're trying to find out where x equals 38. And if x equals 38, we can see that that is not in our window. We'll have to adjust that so that's a little bit bigger. I'm going to use 40. If this is many years down the road, you may have to adjust that to 50 or 60 or 70 or 80, depends. And then hit graph. And then we can trace. Right now we're on the plots. It lets you find, if you arrow over, it shows you all your ordered pairs. But we want to trace along the curve. So you just arrow up, and now it says the curve is highlighted. So we can type 38, enter. Okay, so our answer is about 10.21 hours of daylight. Okay, and we're thinking, does this seem reasonable? Well, if we're thinking that this is periodic and we're seeing the same pattern over and over again, then February of 2023 should be similar to February of 2020, our original data. So you would want to compare it to your table value, okay, the original value, and see if it's pretty close. Okay, so if we go back here, February here was 10/17, okay, and then you compare that and think, is that reasonable? Your last task on this one is going to ask you to Google, okay, use the internet. It says compare this to the actual data from that day. So what I want you to do it for me is look up how many hours of daylight there were for Hays, Kansas on February 1st of whatever year you're watching this in. And I want you to compare that to the number that you got up here to answer that question. Last thing we're going to do is talk about one more application. We're spending 2 days on applications because they're important. I want you to see as many different ways we can use this information as possible. So here's another one. It says a pendulum swings back and forth in a vacuum. A vacuum just means without atmosphere. At Fort Hays in Tamanic Hall, they actually have a pendulum, and it ranges multiple stories, but it's this big swinging item. And even if there's no wind, no atmosphere happening, okay, that pendulum is going to swing back and forth based on the rotation of the Earth. Okay, and it just is constantly swinging back and forth. So this one is periodic because we're swinging back and forth, we're going up and down or side to side through the same values. Okay, so we're going to talk about what this is measuring. If you look here, our maximum value is 1.5 and our minimum value is 1. And what we need to know is, what is that talking about? Maximum what and minimum what? And so looking at our y-axis, it tells us its distance but it's distance measured from some point. And it says here it's the pendulum's distance measured from a motion detector. So it's swinging back and forth, side to side here, okay, and it gets closer to that motion detector and then away from it, and then closer and then away from it. So it never actually touches it because it's always 1 meter away at least, and then it swings further away based on that. So now that we know that, we can write an equation because we know from our experience and our practice just a little bit ago and last class what pieces from the equation are going to, or from this graph, are going to help us write the equation. Okay, so some things we need. I like to start with midline because I can visually see from a graph the middle, and that is going to be the k always. So these numbers are a little nicer than our last problem. We don't have to do crazy math. The halfway point between 1 and 1.5 is 1.25. And then our amplitude is that distance up from there. So that's 0.25. And then period is the length it takes to complete a cycle. Okay, so you can start, remember, at any point you want to, and it's the distance it takes to get back to that point. Okay, so you can start literally at the start and figure out when it repeats itself, or you can start at the maximum and go to the next maximum. It's up to you. It depends on your scale. Okay, so think about what that period would be. How long does it take to complete one cycle or one lap? Okay. Hopefully you're seeing it's 2 from this version, but also max to max. This right here is about 0.5. This right here is 2.5. Distance is 2. Now, just like the last time, when your period is a regular looking number like it is here, this is 2 seconds specifically, when that's happening, you are going to have an equation that has pi in it, just as a heads up. Okay, so let's go ahead and talk about parent function because that's going to help us with our last item we need, which is h. So I told you parent function gets to be your choice. You get to pick sine or cosine. In this case, it is way easier to use sine because sine is a graph that starts at the midline versus starting at the maximum. So we would have an h value of 0 if it's sine. If it's cosine, then we'd have to find this point, and that's about 1/2. I'll show you both here. And you get to pick, and in general, make your life easier, go with the one that you see easiest first. So we're going to start out y equals always, and then we're always starting with the amplitude, so that is 0.25. We decided sine was easier, so I'm going to start with that one. And then we are using the period to solve for a. The period is not a. The period is not the reciprocal of a. You have to solve for it and then take the reciprocal. So over to the side, set 2 equal to your 2 pi a, and get a by itself. Especially for these problems where there is not a pi on this x-axis, write it out so you don't put pi in the wrong place. Okay, because we talked about this, there's going to be a pi left over after you simplify. But this pi is on the bottom, so we have to write it as 1 over pi. And if a is 1 over pi, then in the equation we're going to see pi over 1 or just pi. Now because we didn't have an h, we don't need to put extra parentheses because we're not going to add anything or subtract anything inside. And then we'll just put our k at the end, which is our midline, to finish up. If we use cosine, most of the pieces stay the same. But we will have those extra parentheses because we are subtracting that number, the 1/2. And you could call it 0.5, doesn't matter to me. I like fractions anytime we have something out here that would be easier to distribute through. But in this case, it's not so bad. And you would have just one step. I never want you to leave double parentheses. Always distribute that through. So this one would look like pi x, and then minus pi over 2, or 1/2 pi. Okay, so sine is a lot easier for this one. Okay. Homework is going to cover a lot of calculator stuff and some applications with some review. Please come see me if you have any questions.